Welcome to Sweet Spot Maths, the gold standard for A-level maths teaching. I'm David Forster. This exam revision session is based on the Edexcel Paper 1 from 2019, and in this part I'll cover questions 1 to 5. The first question in this paper is based on the binomial expansion. Find the first 4 terms in ascending powers of x of the binomial expansion of 1 plus 8x to the half, giving each term in its simplest form. So we apply the binomial formula to 1 plus 8x to the half equals 1 plus n times 8x, n in this case being a half. The next term, the coefficient is a half times minus a half over 2 factorial times 8x squared. The third term will be a half times minus a half times minus 3 over 2, taking 1 off each time, over 3 factorial times 8x cubed. I recommend you write down this pattern and the full coefficients to make sure of those working marks. For the final mark, we need to simplify the coefficients. It does say each term in its simplest form, so we don't want a half times 8, we do want 4. 1 plus 4x, take 8x squared plus 32x cubed, etc. It's 4 terms we want. If you give extra ones, they will probably ignore those, so long as you've got the first 4 correct. Ascending powers means simply we have 1x, x squared, x cubed in that order. Part B. To use part A, explain how you could use x equals 1 over 32 in the expansion to find an approximation for root 5. There is no need to carry out the calculation. This is an explain question. That means that it's not the numerical answer we're looking for, it's the explanations here. So the obvious thing to do is to take 1 over 32 and put it in part A. So 1 plus 8 times 1 over 32 is 5 quarters to the half. Apply our roots of surds to get root 5 over 2. There's our root 5. On the other side of the equation, we have 1 plus 4 32ths minus 8 times 1 over 32 squared, add 32 over times 1 over 32 cubed. To get root 5, we multiply by 2. Now I've written down here the requirement that mod of 8x must be less than 1 for validity. That's what's required in binomial expansions, where the power is not a positive whole number. That is the case here. A quarter is less than 1. Looking at the mark scheme, they don't actually require you here to say that it's valid because 8x is less than 1. But I think it's good practice. You should think of this, because every time you do an approximate expansion, you need to think, for what range of values is it valid? Question 2 in this paper is on logarithms. By taking logarithms of both sides, solve the equation 4 to the 3p minus 1 equals 5 to the 210, giving the value of p to 1 decimal place. So we take logs of both sides. It doesn't matter what base we take logs to in this question, so long as we do the same for both sides. We then apply the power rule to take the 3p take 1 to the front, and we're actually also going to take the 210 to the front, although I've left that to a slightly later stage. So 3p minus 1 is going to equal 210 times log 5 over log 4, which is 243.8. Rearrange by adding 1 and dividing by 3, and we get 81.6. The question says 1 decimal place. Let's make sure we do that. So logs to any base will do. Base 10 is the obvious one to use here. The markers seem quite insistent in their mark scheme that the 210 must be taken to the front as well, so powers to the front in both cases. Some calculators will actually do 5 to the 210 and the log of it. Mine would, but not all will. I think the common mistake in this question would be to mishandle log 5 over log 4. A false rearrangement of that, maybe writing it as log of 5/4, would be a common mistake. Question 3 on vectors. So we have the points A, B, and C, and the point 0, the origin, and we're given them in IJK form. And the first part is to find AB. The formula is that AB is OB take OA, do the subtraction, and get the answer, which you can either state in IJK form or as a column vector. Part B, show that quadrilateral OABC is a trapezium, giving reasons for your answer. It's a show that question, so we need to make sure it is explained fully and correctly, and without irrelevant material. So thinking of OABC, we have a quadrilateral here. We need to show, for it to be a trapezium, that AB and OC are parallel, or alternatively, that OA and BC are parallel. So I'm looking at OC. OC is 2i take 16j add 4k, which is double the answer to part A. It's double AB. So given it's double AB, those opposite sides are parallel and it's a trapezium. Note, vector answers may be stated in IJK form or as columns, but don't state them as coordinates. We don't want brackets 1 minus 8, 2 in part A. It's a vector, not coordinates. And the other point here is, in show that questions, do not include extra irrelevant information. That will detract from your answer. So for here, for example, we don't need to think about OA and BC and whether they are parallel or not. Not needed. We've already answered the question. The examiners make the point in their report that a diagram of OABC, while not essential, will probably be helpful. Question 4 is on function notation. We're given a function. The domain is the real numbers excluding 2. And part A says find the inverse function of 7. There are actually two ways of doing this. The way I've chosen to do it is to find f inverse. The routine for this is to exchange x and y and rearrange. So x is 3y take 7 over y take 2. Rearrange it to find y. So that will be f inverse, and put 7 into it to get 7/4. Part B of the question asks us to show that f of fx is of the form ax plus b over x take 3, where a and b are integers to be found. So f of fx means take fx and put it into its own formula. So in other words, it's 3fx take 7 over fx take 2. So do the algebra. Multiply by x take 2 on top and bottom, simplify, and get 2x take 7 over x take 3. Is that of the correct form? Yes, it is, where a is 2 and b is minus 7. If you don't get the correct form, that's a strong indication you've made a mistake. It's a show that question, so they do want to see the steps of the question. Now, I said there was another way of doing part A. Instead of finding f inverse of x, you could simply have put 7 in the position of fx and rearrange to find x. The steps are pretty much identical, to be honest. Whichever way you do it, make sure you show the details and get the answer. Question 5. A car has 6 forward gears. You might think, is this a mechanics question? It's not. It's actually about sequences. So we're told the first gear, fastest speed is 28. Sixth gear, the fastest speed is 115. It's a sequence. In part A, it's an arithmetic sequence. In part B, it's geometric. So in part A, we're asked, find the fastest speed when the car is in third gear. In other words, given term 1 and term 6, find term 3. So the test here is to use the formulas for the term of an arithmetic sequence correctly. Don't make the mistake of using the summation formulas, not required here. It's the terms we're dealing with, not the sum of terms. So the first term A is 28, and the sixth term A plus 5D is 115. Rearrange to find D, 17.4, and therefore the third gear will be A plus 2D, 28 plus 2 times 17.4, 62.8 kilometers per hour. Now, it's good practice in a question like this. In fact, you should state the units. The mark scheme says in this question, they will condone lack of units. Condoning something means technically it's wrong, but they're not going to take any notice of that. So in this question, there are no marks for the units, but in other questions there might be. So good practice, put them in. Part B of the question, we're doing the same thing except treating the sequence as geometric. So the first term A is still 28. The sixth term, AR to the 5, is 115. So R to the 5 is 115 over 28, which is 1.3265 to 4 decimal places. So the fifth gear will be AR to the 4, which turns out to be 86.7 kilometers per hour. That's not exact. What degree of accuracy do we require? Well, it says on the front of the paper, 3 significant figures unless stated otherwise. So 86.7 kilometers per hour. Common mistakes on this sort of question would be to treat the sixth term as A plus 6D or AR to the 6 instead of 5. And another mistake would be premature rounding in part B. If you wrote down R as 1.3 and used that, you would get an inaccurate final answer and would liable lose the answer mark here. And as I said, inexact answers should be given to 3 significant figures unless stated. So those are questions 1 to 5 of this paper. In the next installment, I will cover the next questions starting from number 6. This is Sweet Spot Maths, the gold standard for A-level maths teaching, where we do maths in the sweet spot, fine-tuned to achieve A star without wasting time. We shift our perspective to think like a mathematician, so we can complete even the hardest exam questions correctly and confidently. And thirdly, we learn those exam secrets. We should know the gaps, mistakes, and omissions of most other candidates to gain the examination edge. I'm David Forster. If you want to know more about Sweet Spot Maths, you can email me on support@davidforster.org.uk. Thank you for listening to this instalment of Exam Revision Sweet Spot Maths, and I look forward to you joining me in the next instalment.